Well, I've been told the sound is okay, so let's go.
Hey folks, welcome to part 5 of the CNC adventure here at the Luthier's Lair and Gary Denyer custom bases. You might hear some odd noises in the background. Yeah, I'm going to be getting right into that in just a minute. This episode will detail the use of G-code files exported from Fusion 360 into Carve Motion, and then we're going to simulate, without using any material, any stock or anything, how the machine's going to move. So I'm not ruining anything. I made sure my code paths, tool paths are correct. The simulation, well, let's go look at the software, shall we? Or actually, I'll show you this ghost cut first, right? Okay. So, what am I doing here? Well, listen to that. I have no tool in the spindle. The spindle is not on, the vacuum extraction system isn't on. I'm actually simulating one of the G-code files that will cut out a 3D Carve for the redesigned Falcon Series 2 Deluxe model. As you can hear, the acceleration and deceleration of the stepper motors to follow the carves that I specified in the G-code. This is an interesting part. It skips out the bridge recess because it's already done, and then goes round and it's going into the belly carve now. And it's doing the fillets, roughing out the fillets on the side of the guitar here, and round to the neck where it will stop. You hear that? And it's just putting fillets on right there. It's hilarious. It's really funny. Now that you've seen that, I'm going to show you some stuff in Fusion 360, actually in the web browser version of Fusion 360, not the actual software itself. It's on another computer that I don't like putting anything else on except for 3D stuff. But I can browse the project and show you what I did in Fusion 360's web-based viewer. So let's go and take a look at that, shall we? Brilliant.
Yes, thank you very much. I hope that's not too loud. Ritesh says, are you an engineer or a draftsman? I have some background in it. I used to do a lot of 3D game modeling using things like Milkshape and 3D Studio Max, stuff like that. Fusion 360 is a much a different proposition though, and I'm going to guide you through some stuff in Fusion 360. It should be fun. Anyway, welcome to part 5 live of the CNC adventure. For those of you who don't know, I bought a Shapeoko 4 CNC machine in an attempt to retool my workshop. This entails a lot of design, a lot of stuff like that, but once you get the design part down, the CAD part down, and the CAM part down, then it'll drastically reduce my production time, and also up the accuracy of each build, because I have getting problems with the hands working, getting older and stuff. So I thought CNC was a good move for making bases. Ritesh again says, where did you learn CNC machine from? Well, I can give you a bit of history about that. In the 90s, the early 90s to be specific, when I worked at Hughes aircraft company, Hughes Microelectronics in Europe, I was able to gain access to a tool shop, and it was an old Bridgeport mill that they were using there. You know, one of the hand-operated ones. It was awesome. It was really good. You could do anything with it. And it cut aluminium, or aluminum, as they say here. Yes. And all sorts of stuff. And I learned a lot from those tool makers in the day. They were fantastic guys. They were always open to me asking questions of them when I worked there. That was fantastic, that little bit. But that's where I learned it from, and you know, I've just not used that skill for, well, 30 years, I guess. But things have changed radically now, and these tools have become much more affordable to, let's say, hobbyists or small businesses. So this is really the path I want to go down, and it will be cool. It will be very cool. And I do have a bass on standby, you know, for playing if the inkling takes me. By the way, there is no Angus today. I'm sorry about that. Angus is actually on vacation on Mars. Yeah, that's where he is. So it's a terrible thing that Angus won't be with us, but you know, stay tuned, because he's going to be back with a lot of stupid adventures. So yeah, be pleased to see Angus back. Ritesh says, do you know any courses that teaches CNC? No, I don't. I'm all like I said, you know, back in the day, I was self-taught. And if you actually, I could pull up something here. Let me try this. It's the first time I've tried this live, so I do subscribe to a guy who makes guitars with CNC, and let me try this. Let me see if this works. I'm going to copy this in here. Check out this guy on YouTube, Ritesh. I'm going to put this in the comments. And this guy, I've learned a lot from this guy in Fusion 360, the software that I've chose. Now, here's what happened, okay? I bought the machine, and it comes with a piece of software called, the machine, of course, is a Shapeoko 4. It came with a piece of software called Carve Create, and it's fantastic for what it is. It does a lot of good 2D carving. You can make trays and utility trays and stuff like that, and I did a lot of that for the machine itself, you know, trays for hex keys, tool bits, clamps, stuff like that. But it has difficulty with contours. Even when you import an STL file, which is a mesh, a 3D mesh, it has difficulty with that. So I thought, you know, I'm going to have to try out Fusion 360. Oh, gee, sorry, lunch. And yeah, so I've been learning Fusion 360 over the past week. Like I said, I have a head start on things like that because I've done a lot of 3D design before and CAD before. Let's hop into it. Let's have a look at the chat first. Laurent says, "Hi Laurent, how you doing, man?" Yeah, good to see you back. As you can see, you'll see the bottom of Lula there. She's hanging up. I want to do a couple of details to her, as we've discussed. But anyway, Laurent says, "Why did you choose Angus? Where does it come from?" Yeah, the character Angus is a very common, very Scottish name. And although I've lived in the US for more than half my life now, 28 years actually, 2 days ago was the anniversary of my moving here. 28 years. I still sound Scottish and stuff, and kind of Scottish, you know. So anyway, thanks, man. Yeah, I like the t-shirt too. It's awesome. Cost a fortune though, you know. Fucking rip off. Anyway, would you like to see the redesign of the Gazzbass Falcon Series 2 Deluxe model? Would you? Would you? Would you? Let's go and take a look at this right now, okay? So I'm going to go to my main desktop, and there it is. Yes, indeed. That is the redesign. Now I'm going to have to sort of shift my head. I do have an inset camera there, as you can see, but I'm going to have to shift my head around to see the screen in front of me. And there it is. That's it there. Let's have a look at the top of the model, and let's go this way, and we'll zoom in a little bit. And that's the redesign. Now you'll note that I've gotten much more daring with the fillets around here, and around here, around here. There's a step there, which I thought was awesome. I was thinking about making it bigger, but I won't. Goes around here, and then there's a cavity here because, of course, the Falcon Series 2 is a headless base. It's a headless base. Just like Ichabod Crane, but he had a high-pitched voice, so he's not bass at all. So yeah, and then we've got the arm carve here, which is extra big. Actually, I should give a shout out to the great Franco Di Donato here. Yeah. Who was involved in the design of the first Falcon Series 2, and his main drive with this and his main like was that he loved the way it just fit, because he wears the bass kind of high, so it just fit under his shoulder beautifully, and he could reach all the other parts of it. Now let me just should I go this way? Yeah, there's the side profile. Let's have a look at the back, and let's rotate that into view for you. There's the belly carve, which is a big belly carve on this base. I made it even bigger than the original design, just because I thought it was awesome. And then back to the front again. So this is the actual design. This particular design has the front control cavity, and in this design it's recessed. I'm going to show you that right now. Just see that there's a recess there, and this is the control cavity. I will be offering it also with a back control cavity, so that there's no front control panel there, and I'll just quickly show you the control panel, which has been streamlined. The control plate, of course, is called. I streamlined this to make it a little bit smaller, and that's it in manufacture mode. Let me go back into design mode here. Go from the top and then come round. So that's it from the top. And of course, this is a switch for LEDs on and off in the neck, brightness of the LEDs, pickup blend, volume, master volume, bass, middle, treble. And these two switches are for the soap bar pickups. They're dual coil. Series parallel bridge pickup, series parallel neck pickup, and you can see that right here. So that's the bridge and the neck pickups there, and they are slimline dual coil noise cancelling soap bar pickups by the great Seymour Duncan. So yeah, that's a brief overview of the design. Let's take some questions now. Excuse me. Yeah, questions. Ritesh says, which software you use for making the drawing? Fusion 360 by Autodesk. The people who made AutoCAD. AutoCAD's been around for, maybe 35 years now. The AutoCAD software, but they have different pieces of software. They have AutoCAD Lite, they have Fusion 360, they have a bunch of things for doing stuff. Now, Fusion 360 has a large learning curve, and I'm just going to show you some basics right now. If we go to the top view, so how did I even start doing this? Well, they're called sketches. So if I hide the model of the body here, I should switch to this view. Sorry about that. I'm going to hide the body. Okay. Body's gone. Nothing there. There's the sketch though. This is the actual sketch I made of the Gazzbass Falcon. So it is slightly redesigned. This used to project up a bit here and go round more like that. But these cutouts are the same. The neck pocket is the same. The neck and bridge pickups, of course, redesigned for dual coil soap bars. And I narrowed this region in a bit more, and that's for the tuning of the headless bridge system. So I just drew these out, and these dotted lines are called construction lines. And it's good to set that up. I'll show you actually a construction sketch here. I'll hide that one. This is what I based everything off. These are construction lines. So when you go to actually model it in 3D, these do not get taken into account. So that's a fantastic thing. So we'll highlight this sketch again. So you can see that's the basic outline of the base. It's fantastic, right? And I do have dimensions turned off and stuff, but there's a whole load of dimensions in here. If I go into edit that, I won't save. You'll see there's all the dimensions, all the constraints. Like this is right angled to that. This is parallel with that. So is that. This is all parallel, right angles, and of course there's a taper here for the neck. And I'll show you the neck design a little bit. So if I undo that, because I won't be saving this anyway. So that's the basic sketch for the body. So if I hide that and show the body again, there it is. I also put in the actual stock for the body. And there it is. That's the blank that I'm going to cut it out of. And you can see the base hiding under there. And of course this is hidden. The arm carve part is hidden. And if I sort of flip over this way, you'll see as well the back, the belly carve is in there too. And I'm going to show you some cool simulations in real, well, not in real time, because it would take about 2 hours, you know, to show you that. But anyway, let's switch off the stock, and there we are, back to that. So that was the body sketch. I do have a number of different sketches here. If I hide the bodies and show you, this is just a basic line here for reference. Then there's my stock sketch. That's for the comfort carve for the arm, and that's for the loft for the comfort carve. Again, another reference line, another reference line. That's the belly carve right there. That's for the control cavity, as you can see. Fantastic stuff. And let's hide that. And that's a projection of the cavity to make the plate, the control plate. And that's the contour of the body with a lot of reference points on there. to get me the right dimensions for it. So that's what goes into it, really. I mean, it's no mean feat to get something like that built. And I only started with Fusion 360 perhaps about 10 days ago, so I've learned quite a lot. Let's move that over there and zoom in a little bit so you can see it better for those of you on mobile. Okay, let's take a couple of questions here, and then we'll go on to actually what it took to machine the thing, if you like. Oh, and then I'll show you other parts of the base after that. So, yeah. Ritesh says, do you know the difference between AutoCAD and Fusion 360? Yeah, well, AutoCAD is usually for more 2D style designs. Although it is used for 3D, AutoCAD itself, I think it's been superseded now by Fusion 360. Back in the day when I was using AutoCAD about 30 years ago, I could do machine parts and stuff with it. So I'm not quite sure how to delineate them. What I do know though is that the products are very expensive. So what I had to do was evaluate this, make sure I had a good grasp of it before I decided to commit to doing a subscription to it. Of course, you don't buy software anymore, you subscribe to it, you know. They get you at every point, but you know, and Fusion 360 is a hefty investment, so we have to be very careful with that. If I find that I can't successfully do something in a piece of software within a reasonable amount of time, then I'm not going to go with it. You know, I'll try something else. There is another piece of software out there called Rhinoceros, or Rhino 3D, which is similar learning curve. All 3D modeling is, you have to think three-dimensionally, and you'd be surprised that most people really don't think three-dimensionally. We just take it for granted. Shapes, geometry, stuff like that. It's tough. It's tough, but if you want to do it, I would go ahead and do it. Laurent says, that shape is cool. Thank you very much, sir. Thank you. Yeah. Wait till you see the machining part of it and the simulation of shaping it all out, because this software does it all. It simulates the spindle, the machine, everything. That's really cool. Have I been outside in the last 10 days? No, but I do plan to go outside tomorrow when the weather clears up to take some photographs of a certain base. But there you go. Let's get on to, shall we? Let's get on to machining. Now, Fusion 360, if I switch back to the main desktop here, comes with workspaces. As you see there, there's design. This one's grayed out because I'm a personal user of Fusion 360. There's render, which is nice. I'll show you that later. Animation, I do not need. Manufacture, which I'm going to go to next. And drawing, you can do some drawings from a design on an animation of any sort of model type. Very flexible. So the first thing we're going to do, actually, just switch that off so you can get a better view of this, is we're going to go into manufacturing. And this is the manufacturing workspace, and as you can see, there's a yellow border around the whole base now, the body of the base. So what's that for? Well, it's to show you where the stock is. That's where your stock piece of wood, the block that you're going to carve this thing out of, that's where it lies. And there are origin points on there. We have name views here, the model itself. Let's see the origin of the model. Let's see the origin of the model. It won't show it. It takes a long time to calculate stuff. But anyway, the most important part here, and as you might expect, is all the tools that you need to use to cut the shape out. Now, these are called setups, and I have 1, 2, 3, 4, 5, 6 setups in here because the personal copy of Fusion 360 does not allow you to do the whole thing in one setup. If I want to go, I'm going to get to this later, but up here, post-processing, this allows you to export what's called a G-code file for processing on your machine. And the machine understands this thing. Sorry, I'm going to take a little drink here. I'm kind of thirsty. Hold on. Sorry about that. Yeah, so that's what that does. So there are a bunch of little workspaces here that you can see. If I just minimize that, you can hide and show things, as you can see there, there, and then the setups. Now I don't know if I'm showing the stock here. Am I showing the stock? Yeah, whatever, doesn't matter. I'm going to show you some simulations now. So the first thing I set up here on this body was to use a tool on the machine to carve out this, and this. Okay, so the first operation uses all the same bit, which is 1/4 inch down cut 2-fluted end mill, and you'll probably see that here if I do that. There it is there. Okay, and of course the next operation uses the same tool. I cannot switch tools in one setup because of the limitations of the personal copy, but what I'm doing is I'm getting used to using the software now, so if I do choose to purchase a subscription, I know that I'm going to be good. So let's actually simulate this first operation here. Okay, here we are with the blank back in, and let's have a look at simulate and see what that does. Now notice what happens here. I've got an option here called comparison that will show me the model in green and my stock in blue. If I went to material, everything goes bland. I like to see what's getting cut out, so I always go to comparison here. Okay, now if I just orient this a little bit so it's more orthogonal, so you can see what cuts it's going to be making, I'm going to start simulating this. I'll back off in the speed there, and this little play button here, I'm going to start that, and let's see what happens. There you go. That's what the machine will do, but it won't do it that quick, of course. You know, it won't do it that quick, but that's actually what the machine's going to do. And if I turn off all these lines here, you can see actually what the machine, and there's the little bit there, has achieved. And it's left me nice fillets in the corner here, nice and rounded off to, that's 0.125 of an inch radius, diameter actually, no, radius. It cut out the neck pocket and the control cavity and the recess for the control plate, which is 0.125 of an inch deep. Let's do that again, and let's slow the speed down a little bit so you can actually see what's going on. Let me pause that again. Let's start again. So there you go. There it goes. That's cool, right? So you can actually go in after the fact and look at the pockets. during simulation to see that it's doing what you want it to do, and if it doesn't, you go in and you edit your tool setup and stuff. That's far too complex to get into in this video, but I'm going to speed this operation up because this takes a long time. So you can see that's much faster. Okay, and statistics, that takes 41 minutes to do, and I'm not cutting aggressively at all in this simulation. I might be able to cut more aggressively, but I do not know until I get a piece of wood to actually cut. I want a 1.75 inch thick blank by 14 inches by 20 inches, and that sort of wood's kind of expensive, so I want to try a crap piece first to make sure all my calculations are correct. So that's a good simulation there. And then we've got this one, which is the actual body carve itself, and I will just simulate that, and it won't chain the simulations together. I'll do a full simulation at the end here, but as you can see, just pretend these areas are being cut out, and here we go with the contour carve. Now what I'm doing here is I'm going halfway through the stock, halfway through, because I have to flip the piece over in order to do the other side. But as you can see, look, it's roughed it out. It's still to smooth it. So the next operation I need to do is this one. There's a fine carve on the top here. So let's simulate that and see what goes on. Ready? And you can see it's cutting it very smoothly. And the tool I'm using for that is a 1/4 inch ball end mill. And you can see the material going away. Once all the blue stuff goes away, turns to green, you know your tool path's cool. And there it is, starting to do the belly carve much better. And as you can see there, oops, sorry about that. See? It's lovely, isn't it? It's very nice. So that's really nice. Quick question from Laurent. Is it me, or have you changed the old shape on the bottom? Yes, I have a little bit. As you can see there in the simulation, the bottom's slightly more rounded, but has a dimple offset cut there, which I thought would add some flair to it. So it does look rather funky, but it does look nice, and I'll show you the final cutout. Okay, so that's that operation. Now the next operation is actually going to be flipping to the back of the base, and let me show you that. So actually, let me drag that around manually. Bottom, and we'll scoosh this in. So you see there, in green is the model, in blue is the stock. And if I go to back carve here, show that and simulate that, you will see what happens. This is a rough carve out that it's going to do of the back. So that's what's happening with the tool. We just go ahead and simulate that. I'll speed it up a little bit. Computer's hanging up again. Yeah, it's not getting all the way through this simulation for some reason. It was working earlier, but don't worry about it. Okay, so we can go to the fine carve and we'll simulate that. I'm pretty sure that'll be able to be simulated. Yeah, it's holding at the same. No, there we go. Let me max out the speed, and you will see little pieces disappearing. I'm doing this all on the same computer, so the processing power is formidable for this. So you can see it roughs all that out and it smooths it out, and you'll notice here I've left some stock here, and that's because I'm scared. So really on the first piece that I do, I'm not too bothered about that. I can sand that out, that's not a problem. Kind of defeats the purpose, but I want to make sure I've got everything absolutely precise. And then the final operation in cutting this guitar is the final body contour, which will cut all around the perimeter of the base, but it will leave what's called tabs inside here, so that it doesn't cut the piece free. If I cut the piece free, shit is going to fly across the workshop, you know what I mean? So I don't want that to happen. So we'll simulate this, and we'll go ahead and I'll cut out all this stuff. And what we have in the end is those little tabs. I don't know if you can see them. They're down there. But if I show you the full simulation, that's a tab there, and that keeps this all this connected. So when the piece is finished, I will take the piece off the CNC machine, and I will liberate the piece from the stock just by cutting the tabs, and it'll come out, and then I'll sand the tabs away and you'll never know they were there. So let's simulate the whole piece, shall we? Let's go for a full simulation of this, and I will mute and I will let this thing go at almost maximum speed, and then I'll show you the statistics later of how long it's going to actually take. Okay, so we're going to simulate, and we'll back off a little bit on the speed, and let's go. I love a good simulation, don't you, mate? So it looks like it's finished. And let me just zoom in to see. Yep, it's cleared, and there's the tabs I was talking about there, and around there, beautiful fillet lines, tiny bits of material left, but that's okay. It should be ready for like 220 grit sanding after that. Drag that over here. There you go. Let's have a look around this side. And everything is cleared. And that went through the stock there, but that's okay. Let's bring this down a little bit. Oops, sorry about that. There you go. There's a tab in there holding the body in place. A tab there holding the piece in place so it doesn't fly across my workshop. Lovely. And that's basically it. You know, what happens with the tool, I'll quickly show you like one tool setup. If I go in here, let's exit this. Let's switch this round. Excuse me. So the first tool operation here is to do all these things. Carve out this pocket, this pocket, this pocket, and this pocket. And I use this, and here's all the tool parameters, which you can set up from the manufacturer depending on who you buy the tool from. So that's fantastic. Then we go into geometry and we choose the pockets we want to route out. Of course, this first one is the neck pocket. I choose the bottom reference as that the face of that pocket, as you can see there. There's the face I chose. And then there's passes and stuff. You have to learn all this stuff to make sure that you're getting it okay. And so forth. So that is the body. Let's go to render now. Let's go to the render workspace, and you can see there's a nice rendering of the base itself, the body of the base, and the shape. And you can see those beautiful contour lines in there coming through. If I flip it over, of course the lighting is different on the back because I've not set up the lights, but there's the belly carve right there. And I'll flip this over again, and there's the arm carve right there. Beautiful. And that's it. And it's built precisely to the specifications that I wanted it to be built to. So, fantastic, right? Yeah. Yes, a lot of fun. I'm going to quickly show you a couple of other models from this base. Laurent says, yeah, new Atari 2600 game, yeah. Pac-Man, Donkey Kong, Space Invaders, yes, I loved that machine. Tell you, when I first got that machine, I was up all night playing it. I mean, I was totally addicted. It was terrible. David Crane would be proud, yeah. So, that's that. Now, I showed you the control plate, of course, so let's close that out. Let's close this out. I don't want to save that. Let me go into... What would you think would be next? The neck, maybe? I'll quickly show you the neck. And you've probably seen this. Hold on. Back to main desktop. There we go. And that's the Falcon Series 2 neck. Of course, it's a headless design. So you have all that stuff going on. There's the truss rod cavity in there. I haven't done tool paths for this yet, but it totally matches the body. You can see there. It's lovely. Yes, indeed. Why, thank you. And of course, I have also the pièce de résistance here. And I think you're gonna love this. I think you're gonna love it. I have a parametric fretboard. What on earth is that? You might ask. Well, I'll show you. Here is a fretboard design that is completely user definable. This model can be used for any base. Any base. Don't believe me? Watch this. Oops. Let me escape out of that. That was the wrong one. Modify. Change parameters. Look at this bunch of stuff. What's that? Well, we have the scale length of on the E side of the base, the scale length on the G side of the base. Now, what does that mean? Well, it means I can make a multi-scale base. I've programmed this so that the frets can be fanned. So I could go maybe make that 32-inch scale. And let's see what happens. There we go. Now we have a fan fretboard with the 12th fret being vertical, this one here, and the scale on the E side is 34 and the scale on the G is 32. Nice, eh? Isn't that awesome? let's go back to constant scale. Got 34, and we're back to this straight frets there. Now I can make maybe a short scale base, 30 inches. Oh, 320 inches is not going to work. 30 inches there, and 30 inches there. And that's a short scale fretboard. Do I want a Gazzbass profile? Okay, let's do 34 there, and 34 here. And of course the nut width is 1.63 on the Falcon, which is more like a P-base. But if you wanted a narrower neck and fretboard, like 1.5, like a Gazzbass, boom, there you go. It changes. Lovely. And if you want a narrower heel, maybe like a Lembic 2.3 for like a brown base type, there it goes. It reduces automatically. And there's the formulas I use to base this off of. Scale factors, that is the distance between each fret to the power of each fret. So that's to the power of 1, to the power of 2, 3, 4, 5, and so on. The thickness of the fretboard, of course, it's 1/4 of an inch. That's pretty standard, so I'll leave it at that. But I have the option to increase it if I want. Now I get right into the tang width of a fret, a single fret, you know. So the tang width is that there. The tang depth, of course, doesn't cut into the fingerboard. If I want an offset so that I've got a hidden tang fretboard, watch this. Offset, let's say minus 0.1 of an inch. And you can see there. You cut the frets so that the tang is hidden. Fantastic. Go back in and set that back to 0. And fretboard fillet, which is way across here. That's the fillet there. The curve on the end of the fretboard. I made that now, but I could do 1/4 of an inch fillet. You see that change there? Or I could do 0, make it square. There is an error there. Compute failed. Why? Yeah, because it's 0. Yeah, fine. Okay. But I'll go back to 0.1. Actually, 875 I had, which I liked. That's a nice fillet there. So you click OK and you're done. You are done. That's ready to tool up now. And I haven't got toolpath set for this particular file yet, but I will be getting to that. So that's that. Isn't that fantastic? Let's go back to the main scene here and let's look at some questions. I think there is. Yeah, Laurent says any bass? Yes, any bass at all, any 4-string bass. That fretboard and neck configuration is made for any bass, any 4-string bass. So you can have scale lengths, different scale lengths, fan frets, stuff like that, which is very hard to do by hand. Very, very hard to do by hand, you know. So, yeah, that's actually basically what I was wanting to show you today. And if you'll give me a little bit of your time, I might just sort of break out the JD. I haven't played in weeks, so yeah, let's get the JD out. Yeah. Yeah, I just smashed my nose off the JD. Anyone hear that? No? Or is it crap? The 51p. Yeah, I can't. I'll break my back. I'd have to go up and get it and stuff, and I'm kind of running short on time, man. So, anyone got any questions on the JD at all? No? Well, whatever. Yeah, it's still my favourite bass. I don't want to emulate it, of course, when I build my own. And I like my own for different reasons. But, of course, when you're young and impressionable, you tend to like certain models that other people build. So, I have no problem with showing off the JD, even although I build my own basses, so it doesn't matter to me. And a big shout out to John Diggins, who turned, I believe, 73 the other week. Good for you, John. It's good to see you can still cut a piece of wood, that's for sure. I'm sorry. Don't play something live that you haven't played in years without practicing. Here's another one I haven't played in years without practicing, but you know. Let's see. Yeah. Yeah, thought I'd do something different, you know. Yeah, so it's been a blast today, guys. I hope you've gotten quite a lot of insight into what's going on here now. Actually, I just yeah, the JD weighs 11 pounds long. 11 pounds. It's a tank. But the bridge is very cool, and I'm pretty sure it was Gibson inspired. The way the strings lie across the JD is very Gibson-like, which is one of the things I really don't like about him, and that's okay. If it's engineered correctly, there's no problems. No problems. Lovely JD. And of course it has that such a distinctive sound, you know. Ooh. It's very hot. Yeah. Anyway, guys, thanks for joining me today. I'm really pleased to be live again today and show you some insights into what's going on here. This is going to drastically reduce my production time if I get the math right in the CAD software. Yeah. And it will help my poor old hands that can't work anymore. So with that, all it remains for me to say is stay safe, be good, and guys, I will catch you the next time. Thank you very much for joining me, and if you haven't already, please, if you like what I'm doing here, subscribe to my channel, click that bell for notifications of any upcoming events, and give me a thumbs up, why not? Cheers. Thanks very much, guys. See you soon. Take care. Thanks for joining me. Bye bye.